That's here. If I also like draw the current that goes through the switches, S1 or S2, it's going to be like this, and then it would be 0. For D1 and D2 would be the second part, would be like this. Okay. And if I look at the IS, this current, it's going to be actually, in the first part, it's going to be like this. In the second part, it's the same as this one, but in the opposite direction. So it's going to look like this. Okay, this is IS. It doesn't matter, just like to show you like different things. So like this is IS, right? Because in this case, IS, it's going to be negative of IO, right? So it's going to be the same thing here, but upside down. But in this case, IS is the same as IO and it's in the same direction. Now, so here, when S1 and S2 are on, current is positive, voltage is also positive, so we are in the forward motoring mode, right? When S1 and S2 are off and D1 and D2 are conducting the current, then current is still positive, it's decreasing, but it's still positive, but our voltage, output voltage is negative. So here it means that we are going to be in this quadrant, right? So what is this quadrant? It means that we are basically in the fourth quadrant, and it means that omega is less than 0, but our tau is bigger than 0. Okay, again, you can see that the direction of the polarity of the voltage and current are opposite, right? So it means that we are having negative power. It means that we are in the generation mode. So this is regenerative, right? But it's regenerative in the opposite direction. So it means like backward regenerative braking. Okay. So this is basically the application of class C chopper. So it can work both in the, this was class D chopper. I'm sorry, it was class D. I forgot to change the name. This is class D chopper. So the application of it, we can have the motor in the forward motoring or in the regenerative braking, but in the opposite direction. So that's the whole point about class D. Okay. Now, actually, let me show you a case where, so we assume that here, like, we have both switches turn on at the same time and both of them are off at the same time. This is not necessarily the case, right? So this is not always the case. We can't have two switches turn on at the same time and turn off at the same time. There's always some delay. So let's actually see how this circuit it's going to operate if our switches are not synchronized. Right, but before I talk about that, let's actually see what the average voltage for class D chopper is, right? If I consider this one T on and consider this one T off, the average voltage is, and this is T, it's going to be 1 over T, which is T on plus T off, times Vs times T on. That's going to be this area, right? Minus Vs times T off. Okay, so if I simplify that, it would be just Vs times T on minus T off divided by the period. So I can write T on plus T off, or just T. Let me just write T on plus T off. Okay, so it means that if the T on is bigger than T off, the average voltage is going to be positive. If T on is smaller than T off, the average voltage is going to be negative. Okay, and you can see that here we have both in forward motoring and regenerative braking at the same time. Okay, so the difference between Class C and Class D is like Class C works in quadrant 1 and 2, but Class D works in quadrant 1 and 4. Now, I want to have one example and ask you if you can figure out how this circuit operates. Let's say if we have this is gating for switch 1 and this is gating for switch 2, right? If it's something like this, let's say like if it's like this, and let's say like they're not synchronized. So like for switch 2, let's say we turn it on at this point and just like this, something like that. Okay, and we want to see how the output voltage would look like in this case. Okay, so let's divide this into multiple time intervals. Okay, this is T. Actually, we can stop right here. So at this point, switch 1 is on, but switch 2 is off, right? So this switch is on, but this one is off. We are assuming that we are operating in the steady state mode, right? So this is off, right? So the current cannot go from switch 2, right? The current, we have a current going through here. It has to find a path. So it basically goes through D1, right? So in this mode, the output voltage, it's going to be 0, right? And we have switch 1 and D1 operating, okay, conducting the current. Then we would have switch 1 and switch 2 working at the same time, right? So then output voltage, it's going to be Vs. So here switch 1 and switch 2. Okay. Then we still have switch 2 closed, but switch 1 is open. So we have some current going through here. It can't go through switch 1. It can't go through D1. It's just going to close itself through D2. So in this case, we would have switch 2 and D2